Okay, so here's the second part of making a common denominator. So in this situation, I want to remind you, I've talked to you about how common denominators, when we have rational expressions, will tend to have a number part, they'll have a variable part, and they'll have a family part. Remember, I call those groups families. So I have a family of x minus 4 here, and I have a family of x plus 6 here. I also just want to caution you with this particular question, I also have a subtract for the first time. And the very first thing I do when I see a subtraction problem is I just go ahead and do the add the opposite, or using Mrs. Carey's language, chum chum. I just want to make sure that I don't drop that negative, so I just move it right over by that number. So looking at building up a common denominator, what I need to do to find a common denominator is I need to include these families. I've got two different families. So what I'm going to do, so the common denominator of these is going to be this family times this family. And we can kind of go back to that first example that I did and look and see, actually it was the back in the day example I did. Remember when we did that, we used the number parts, kind of the same kind of logic. You see that 2 times 5 gave me 10. So it kind of works the same way with numbers as well. Now that will always find you a common denominator with numbers. It may not always find you the least common denominator, but it will always find you a common denominator. So that's kind of the same logic here. So the common denominator for both of these terms is x minus 4 times x plus 6. And this one is x minus 4 times x plus 6. Okay, so what we need to do is we need to build up that denominator to match this one. So what is this denominator missing? It's missing an x plus 6. So I need to multiply the numerator by an x plus 6. What is this denominator? Oh, sorry. So that would give me, keep going, Kay. So that would give me, if I distributed that 3 through, 3x plus 18. All right, let's look at this denominator. To match these two up, I'm missing an x minus 4. But if I multiply the denominator by an x minus 4, I need to multiply the numerator by an x minus 4. Just a reminder, we're multiplying both of these by 1, which means it's not changing their value. So if I distribute a negative x times an x, I would get the opposite of x squared. And the opposite of x times negative 4 would give me plus 4x. All right, and then the last thing to do is to write over one common denominator, going back to our skill from earlier. And then I'm going to combine like terms in the numerators, put them together as one. So this negative x squared has nothing to go with it. I can combine 3x and 4x. That would give me 7x. And then I have 18 plus 18 here. Okay. And then again, I would look to see if I could simplify by coming up with something that factored or that canceled either an x minus 4 and x plus 6. And I'm going to tell you in this case, there is nothing that simplifies, but let me kind of think about it off to the side, just kind of remind you of what we know about factoring. Before I went to factor this monster, I hate that negative out front. So if it were me, I would factor out a negative 1 and say that is x squared minus 7x minus 18. And if that bothers you, just take a second. Don't get mad. If I multiply this through, that's what I get, right? Because I want to factor with those being positive. So what times what gives me x squared? X and x. 18 is, well, it's 3 times 6. I can already tell 3 times 6 isn't going to work. It's 9 times 2. Ooh, I feel like I might be able to get this 9 times 2. So this would give me 2x when I multiply here. This would give me 9x. And if this was a negative, right, and this were a positive, I would get my negative 18 and I would get my negative 7. So technically, this numerator factors as negative 1 times x minus 9 times x plus 2 divided by x minus 4 times x plus 6. Okay, now I want to try to explain something to you. I would accept both of these as answers. I would accept it this way, or I would accept it this way factored. It's okay to stop here because nothing cancels. But the argument is, how do I know nothing cancels until I do this kind of factoring off to the side? So either one of these is okay. All right, so if you leave this as the answer, you're fine. I just was curious to see if what was left, if it would cancel anything here. Because had I gotten like an x minus 4 right here, I could have canceled these to simplify my answer. Okay, last example. All right, so a reminder, common denominators have a number part, that's like our first example. They have a variable part, that's like examples 1 and 2. And they have a family part. So here I have 2 families. So my common denominators are going to be x minus 3 times x plus 1 plus x minus 3 times x plus 1. Okay, hit the pause right now, and I want you to build up both of those fractions. And then come back and see if you did that step correctly. So I'm going to multiply this fraction by an x plus 1 to have these denominators match up. So I need to, got a family here. Got to multiply this family times x plus 1. Which means I have to FOIL these two. Oh, great. Let's see if we remember it. First, x times x, x squared. Outside, x times 1 is 1x. And x times 1, this is inside, is 1x. And last, plus 1. All right, to get this denominator to match up, I'm missing an x minus 3. So I'm going to also multiply the numerator by an x minus 3. And I get 2x squared, if I distribute this, minus 6x. Okay, last step. Maybe. We'll see if we can simplify. Next step, rewrite same denominator, x minus 3 times x plus 1. And now I'm going to try to combine like terms, okay? So if I have an x squared plus a 2x squared, I'm going to have a 3x squareds, okay? And then over here I have 1x and 1x is 2x. And 2x minus 6x is negative 4x plus 1. Okay, so I have a 3x squared minus 4x plus 1. Oh man, I guess I'm not sure if I'm done, because if there's an x minus 3 or an x plus 1 in here, I could potentially cancel it. So I'm going to go off to the side again. I'm going to just kind of investigate this numerator. 3x squared minus 4x plus 1. I've got myself a trinomial, so I'm going to use my rules to factor it. What times what gives me 3x squared? Well, 3x and x. What times what gives me 1? 1 times 1 gives me 1. Now let me check. Inside, 3x. Outside, 1x. Can I get to a negative 4? I can, if this is a negative and if this is a negative. Now, does that work with a positive 1 when I multiply lasts again? Ooh, it does. Okay, so I'm going to write that answer over here. This numerator factors as 3x minus 1 times x minus 1 divided by x minus 3 times x plus 1. Okay, cool. Now let me try to explain this again. I would have to accept both of these as the answers because in this example, nothing canceled. So there's no reason really to write it in this form. But let me say again, the reason I wrote it in this form is what if this would have been an x plus 1? I could have canceled these and this would have been the answer. Now, it turned out I don't have any of the same kind of families, so I couldn't cancel them. So that's why it's acceptable to leave either or of these answers. I'm honestly not sure if in Delta Math they have any that cancel. I know in your textbook they do, so I just want to make sure that you know that coming up could be something that we need to pay attention to. Okay, you're done for the week. Go back and do examples 3 and 4, or do questions 3 and 4 in Delta Math. Have a great weekend.